Have you ever wondered why something as simple as a light bulb can illuminate your entire room? It's a question that might have crossed your mind, and it's one that takes us into the intriguing world of light. Light, in its essence, is a form of energy that our eyes can detect. It's what allows us to see the world around us, from the vibrant colors of a sunset to the words on the screen. It's a fundamental part of our everyday lives, so much so that we often take it for granted. But what if I told you that the light that guides us through our daily lives, that helps us perceive the beauty of the world, is not as simple as it seems? Let's take a journey into the heart of a light bulb, the quintessential source of artificial light. The moment you flip a switch, a fascinating process begins. This process, a seamless blend of science and magic, is what brings light to our homes, our streets, and our cities. But how exactly does this process work? How does a tiny bulb, a simple object made of glass, metal, and a few other elements, transform electricity into a radiant glow? To answer these questions, we need to delve deeper into the world of light. We need to understand the science behind it, the principles that govern its behavior, and the technology that harnesses its power. From the basic components of a light bulb to the role of electricity in lighting, from the science of light emission to the journey of light itself, we're going to explore it all. And in doing so, we're not just learning about light, we're also gaining a deeper understanding of the world around us, of the intricate processes that make our lives easier, and of the scientific marvels that we often overlook. So get ready to embark on a journey of discovery, a journey that will illuminate your understanding of light and its many wonders. By the end of this video, you will understand the fascinating process behind the simple flick of a switch. The magic of light starts with an ordinary-looking object, a light bulb. But don't be fooled by its humble appearance. This little object houses an intricate ensemble of components, each playing a pivotal role in the symphony of light. Let's start with the star of the show, the filament. This thin wire, usually made of tungsten, is the heart of the light bulb. When electricity flows through it, the filament heats up to such high temperatures that it starts to glow. This incandescence is what gives us the warm, comforting light that we associate with the humble light bulb. Next up, we have the base of the bulb. This is the part that screws into your lamp at home, but it's more than just a connector. It's a gateway, a conduit that allows the electrical current to flow from your power source into the filament. Without it, our star performer, the filament, would be left in the dark, literally. Last but certainly not least, we have the glass envelope. This clear casing does more than just offer us a peek into the bulb's inner workings. It creates a protective environment for the filament. The envelope is often filled with inert gas, which prevents the filament from burning out too quickly. In other words, it ensures that the show goes on. So there you have it, folks. The basic elements of a light bulb: the filament, the base, and the glass envelope. Each component, while simple in its own right, plays a crucial role in the grand production of light. It's a beautiful dance of science and engineering happening right there in that tiny bulb. Now that we know the actors in this play, let's dive into the drama that unfolds when you switch on a light. Electricity serves as the director of this play, orchestrating the illumination process. Now let's dive into the fascinating world of electricity and its role in lighting our world. Think of electricity as a river of energy. This river flows into our light bulb, starting its journey at the base and making its way to the filament. The filament is like a bridge that the electricity must cross. However, this bridge doesn't make it easy. The filament is crafted from tungsten, a metal with a high resistance to electricity. This resistance is crucial in our play, as it's the catalyst for our fascinating light show. When the electricity attempts to cross this resistant bridge, it faces an uphill battle. This struggle results in the filament heating up, causing it to reach temperatures as high as 4,000 degrees Fahrenheit. That's hotter than the surface of Venus. Now here's where the magic happens. As the filament gets hotter and hotter, it starts to glow. This is due to a fascinating phenomenon known as incandescence. When objects get really hot, they emit light. This is the same reason why metal glows red when it's heated in a forge, or why the heating elements in your toaster glow when you're making breakfast. But it doesn't stop there. The filament continues to heat up until it's white hot, emitting a bright light. This light is what illuminates our homes, streets, and cities. It's the culmination of a beautiful dance between electricity and resistance, a testament to the power and wonder of science. So, with the power of electricity, our filament starts to glow. But how does this glow light up our entire room? Well, that's a tale for another scene. For now, let's marvel at the fact that a simple flow of electricity can create such a brilliant display of light. The glowing filament is our star, radiating light and warmth in all directions. This is where the magic happens, where the invisible becomes visible, the dark becomes light. But how does it do this? Well, it's all down to a process called incandescence. Incandescence is the emission of light from a substance, like our filament, that is heated until it glows. As the filament heats up due to the resistance it offers to the flow of electric current, the atoms within it get excited, and not in the way you might when you're about to eat your favorite dessert. No, these atoms get excited in a very physical sense. The electrons in these atoms absorb the energy from the heat, causing them to jump to a higher energy level. This state of high energy, however, is unstable. So what happens when things are unstable? They seek stability. The excited electrons too seek stability and fall back to their original lower energy level. This is where the magic really happens. As they fall back, the energy they absorbed must go somewhere. So it's released in the form of light photons, which we see as the glowing light, but not all light is created equal. The spectrum of light emitted depends on the temperature of the filament. At lower temperatures, the filament glows a warm yellowish color, emitting light in the longer, red to yellow wavelengths. But crank up the heat, and the filament glows a brighter, whiter light, emitting a broader range of wavelengths, including the shorter blue to violet ones. This is why we sometimes refer to warmer or cooler light when talking about lighting. The glow from our little filament is now a brilliant light, but how does it escape the bulb and reach our eyes? That, my friends, is a journey we'll embark on in the next scene. The final act of our play sees our light embarking on a journey to illuminate our surroundings. Imagine, if you will, a tiny particle of light, a photon, born in the heat of a filament, making its first steps into the world. The light bulb, its home, is designed to facilitate this journey. The bulb is encased in a glass envelope, a shell that serves two primary functions. First, it creates a vacuum, preventing the filament from burning out in the open air. But perhaps more importantly to our photon, it allows the light to pass through unhindered. Glass has an interesting property. It's transparent to visible light. This means it doesn't absorb the light or reflect it back. It simply lets it pass through. This is why our photon, once generated, can embark on its journey to the outside world. The light radiates in all directions from the filament. Think of it as a stone dropped in a pond. The ripples spread out in a circle, reaching every part of the pond's surface. Similarly, the light spreads out in a sphere, reaching every part of the room. But how do we perceive this light? How does it become a meaningful part of our world? This is where our eyes come into play. Our eyes are finely tuned to detect these photons. When the light reaches our eyes, it triggers a response in the light-sensitive cells of our retinas, sending a signal to our brain. Our brain then interprets this signal, turning the raw data into the vibrant images we see. It's amazing to think about, isn't it? Every time we flick a switch and a room is bathed in light, we're witnessing a journey that begins at a microscopic level in a filament and ends in our perception, transforming our surroundings from darkness into a world full of color and detail. And that, dear viewers, is the fascinating journey of light, from a simple switch to the illumination of our world.